trapezoids, our last section on quadrilaterals. It's a pretty quick section, so shouldn't take you too much time to get all the notes down. Trapezoid, what exactly is it? It's a quadrilateral with exactly one pair of opposite sides that are parallel to each other. So you see I gave you a little drawing here, the parallel sides being the top and the bottom. Typically the parallel sides are known as the bases. You have a base on the top, you've got a base on the bottom. The other two sides are typically known as the legs of the trapezoid. Those pieces of terminology will come in handy as we get into other things involving trapezoids. There is a special type of trapezoid known as an isosceles trapezoid. The thing with the isosceles trapezoid, just like with an isosceles triangle, you've got two pairs of sides that are the same. Same thing with the trapezoid. It's a trapezoid with congruent legs. So remember, the legs are not the parallel sides. They're the non-parallel sides, but they are going to be congruent if it's an isosceles trapezoid. So again, very similar to an isosceles triangle, where if the two legs are the same in a triangle and the base angles are congruent, the same thing holds true for a trapezoid as well. So we've got the trapezoid base angle theorem that says if a trapezoid is an isosceles trapezoid, then the base angles are going to be congruent. Now here's the thing. With an isosceles trapezoid, you've got two bases. You've got the base at the top, you've got the base at the bottom. So what we're going to see is that these two angles are the same, and then the two angles at the very bottom, those will be congruent to each other as well. So the two at the top are the same, the two at the bottom are the same. Some other properties are still going to hold true. These two angles will be consecutive interior angles, so they should add up to equal 180. Same thing holds true for these two angles as well. They would be consecutive interior, and so they'll be supplementary as well. Another theorem involving trapezoids is the trapezoid diagonals theorem. If a trapezoid is isosceles, then the diagonals are going to be congruent. Only if the trapezoid is isosceles. If it's just a regular trapezoid, the diagonals will not be the same. But if it's isosceles, they will be the same. An old friend pops back up. The midsegment. We talked about midsegments back in our chapters with triangles and how the midsegment is a segment that joins the midpoints of two segments together. Well, it's the same thing here, except here it's the segment that connects the midpoints of the legs of a trapezoid. Not the bases, but the legs. Alright, which leads us to the midsegment theorem for trapezoids. And that one kind of smeared. So we've got the midsegment of a trapezoid is parallel to both bases, and it's also 1/2 the sum of their lengths. So if I take the length of the base and the length of the bottom base and add that together, half of that should be the length of the midsegment. So I gave you a little example here. Trapezoid ABCD. We've got a midsegment in the middle here, segment EF. How do I know it's a midsegment? Because these two smaller segments are the same, which means E is the midpoint. These two smaller segments are the same, which means F is the midpoint. So here AB has a length of 12, DC has a length of 28. So if I want to find the length of segment EF, I'm going to add 12 and 28 together. It gives me 40. Take half of that. I know that EF has a length of 20 units. So, not too bad. Add them up, take half, you're good to go. So, a couple examples to take a look at and we'll be done. Example 1. Find the length of the midsegment and the measure of angle M. So here we've got a trapezoid LMNP. We know that LM has a length of 8. We know that PN has a length of 23. And down here, angle N has a measure of 70 degrees. Again, if you want to take a second, pause the video so that you can try to work the example out on your own. now would be a good time to do that. So, length of the midsegment. Right here in green, we've got the midsegment. Again, these are congruent to each other, that's a midpoint. These are congruent to each other, it's a midpoint. Notice, all of our congruence markings are the same. So this is an isosceles. It's an isosceles trapezoid. We'll talk about that in a second. So here's the length of the midsegment. Take 8 plus 23, we get 31. Take half of that. We know that the midsegment is 15.5 units long. How about the measure of angle M? Well, if this is 70, angle M and angle N should be supplementary. So if we take 180 minus 70, we know that angle M is 110 degrees. Now, because it's an isosceles trapezoid, that also means that angle L is 110 degrees. Base angles are congruent. Angle P should be 70 degrees because, again, the base angles are congruent. This is a base angle with angle N. Cool. And so then finally here, example 2, last example of the day, or if you're watching this at night tonight. Find the length of segment AB. So again, here we've got a trapezoid, ABCD. This base is 43. The length of the midsegment is 27. So here we're going to have to kind of work backwards. A couple different ways to go about it. We know that the midsegment has to equal 1/2 base 1 plus base 2. Well, if I know that my midsegment is 27, and I know that one of my bases is 43, it's just a matter of working backwards to find the other base. So if I multiply both sides by 2, that's 54. The half and the 2 cancel out, so now 43 plus the base. Subtract 43 from each side. I know that the base is 11, so that's segment AB. Although there is a little bit of an easier way to go about it. It's the midsegment. It should be in the middle of these two values. So 43 minus 27, that's 16 units. So from 27 to 43, it's 16 units, which means that 27 should be 16 units from the smaller value. So if I take 27 minus 16, notice that gives me 11, which is in fact the length of segment AB. So a little bit easier way to go about it. If you can remember that and it works for you, then great. If you need to go through all the algebra and work backwards, that's fine too. Alright, so that's section 8.6, trapezoids. That's the last section of the chapter. We'll be getting ready for a chapter test pretty soon. See ya.